Welcome to the deep dive. Today we're going to be looking at Python for data science.
Yeah.
It's structured like a week-long crash course.
Oh, wow.
Could you imagine mastering data science in just a week?
That'd be amazing.
I know. Well, that's what this guide is aiming for.
Cool.
It's a project-based guide with exercises so you can really learn by doing. It's
Nice.
super practical. One of the things that I found really interesting, though, was
Yeah.
just how much data is out there.
Right.
By 2020, it was estimated that we create 1.7 millibit of data
Wow.
every second
Per person.
per person.
That's a lot.
Every second. It's mind-boggling, right?
It is. I
Yeah.
think that's one of the reasons why data science is becoming so important, though.
Yeah.
Because we have to find ways to sift through all of this data and actually make sense of it.
Absolutely.
Yeah.
That actually leads perfectly to my next question, which is,
Yeah.
what kinds of data are we even talking about here?
Well, when you think about it, there's a lot of different types of data, but I guess at a high level, you can think of it as qualitative versus quantitative. So qualitative data is more descriptive, like the color of M&Ms,
Right.
or the sentiment expressed in a Yelp review. It's kind of like, the qualities of something. Whereas quantitative data is all about the numbers. So that could be like the price of a product or the temperature outside.
Yeah. Okay.
And what kind of data do you encounter the most in your work life?
Probably a mix of both.
Mhm.
I'm looking at listener numbers and things like that,
Right.
but also reading comments and feedback. So
Yeah.
yeah, I guess both.
Yeah.
But, once you have all this data, what is data science actually doing to make sense of it?
Well, data science is more than just about understanding the past, right?
Right.
We can use it to predict the future
Ooh.
and even prescribe actions to get certain outcomes. Like, for example, think about how Netflix recommends shows that you might like,
Oh, yeah.
or how banks can detect fraud.
That's true.
Yeah.
I mean, I never even really think about that. I guess I just take it for granted.
Yeah.
They, come up with the recommendations or whatever, but I guess there's a lot of data and a lot
A
of...
lot of data, a lot of complicated algorithms running behind the scenes.
Yeah, exactly.
Yeah.
There was one thing in here that really caught my eye, and it was sentiment analysis.
Oh, yeah.
It's just so cool. The idea that you can figure out how people are feeling about a topic
Right.
just based on what they're posting online.
Yeah.
It's wild.
Yeah, it's really powerful. You can analyze like tons of social media posts, for example,
Yeah.
and it can give you a really good sense of how people feel about a particular product or brand or a topic even.
Right.
But, to do that, you need the right tools,
Okay.
and that's where Python libraries come in.
Okay.
Like Pandas and Jupyter Notebook are like essential for any data scientist.
Okay. So what are those? Like, what are they doing?
So these libraries, basically, they provide you with these pre-built functions and tools that like really streamline the whole data analysis process.
Oh.
Yeah, so it's kind of like if you were building a house and you had pre-made walls and windows and a roof ready to go.
Uh-huh.
It's way easier than starting from scratch, right?
Right. Yeah.
Yeah. So Pandas, for example, it's really good at organizing and manipulating data.
Good.
And Jupyter Notebook, that's really cool because it gives you this interactive environment where you can put together code, visualizations, explanations all in one place.
Oh, wow. So it's like the whole package.
It is.
Yeah.
It's like a one-stop shop for data analysis.
Cool.
Yeah.
So we've got the data, we've got the tools. What about the algorithms?
The brains of the operation.
Yeah. I was looking at one in here called Random Forest.
Oh, yeah.
That one sounds kind of crazy. It uses multiple decision trees to make predictions.
So it's like almost like a data-driven democracy, right?
Yeah.
Yeah. Random forest is an example of ensemble learning. Basically, you're combining the results from multiple decision trees, each one trained on a slightly different subset of the data.
Oh, okay.
So instead of relying on just one tree, which can be prone to errors, you're kind of getting the wisdom of the crowd.
So it's like a team of detectives
Yeah,
all working on the same case.
exactly. And they all have slightly different perspectives, different clues.
Okay.
And then they come together and share their findings to reach a more accurate conclusion.
So it's more reliable because...
Much more reliable, yeah.
Okay.
And it can handle these really large and complex data sets.
That's cool. Like, how much more reliable are we talking about?
Well, Netflix reportedly used a similar algorithm
Yeah?
to boost their recommendation accuracy by like 8%.
Wow.
8%. Think about that.
Yeah.
That's a huge difference.
That is a huge difference.
Yeah.
But is there a chance that these algorithms could get, like, too tailored?
Oh, you mean overfitting?
Yeah, overfitting.
Yeah, that is a risk, especially when you're dealing with like noisy data or data that's incomplete.
Right.
It's kind of like creating a recipe that only works with a specific brand of flour.
Okay. Yeah.
It might work great in that one specific instance, but it's not going to be very useful in the real world.
You need a more flexible recipe.
Exactly. So the key is to understand the limitations of any tool
Right.
and use it appropriately.
Yeah. So, we've got the data, the tools, the algorithms, but I got to ask about this section on personalized marketing.
Oh, yeah.
It's crazy how, like, every time I go online, I get ads that feel like they're reading my mind.
Yeah, it can feel a little creepy, can it?
It does. How are they doing that?
Well, it's all about data
Right.
and AI-powered tools that track your online behavior.
Uh,
So your browsing history, your purchase history, even your social media interactions, it all gets analyzed.
right.
And then it creates these really detailed customer profiles. And that allows companies to target their marketing messages with like laser precision.
So it's not mind reading.
No, not quite mind reading,
Okay.
but it's pretty close.
Yeah, it really is. Um, so they're doing that, but is it actually effective?
Oh, absolutely.
Okay.
The book cites a statistic that 75% of marketing agencies say that personalized marketing helps them build stronger customer relationships.
Yeah.
And when you can offer customers what they want, when they want it, it makes for a much more positive experience.
It's less about just pushing products
Right.
and more about like building a connection.
It's about understanding your customers on a deeper level.
Yep.
And using that knowledge to make their experience more valuable.
Okay. So what you're saying is all of this stuff that we're talking about, it's not just
Yeah,
about the numbers. It's actually about like real people
absolutely.
and how they
Or
interact
businesses.
and things like that.
Yeah, at the end of the day, it's all about connecting with people.
Yeah, that's a good point. So we've done a lot in this first part of our deep dive. We talked about the different types of data,
Right.
the libraries, the crazy algorithms like random forest, the potential of personalized marketing to completely change how businesses connect with customers.
Yeah, it's really exciting stuff.
Yeah. And this is just the first part.
Just the beginning.
There's still a lot more to uncover, so stay tuned for part 2.
Yeah, we'll be back. One of the things that really stood out to me is how data science is being used in areas you might not expect, like cybersecurity, for example.
Oh yeah, cybersecurity, that's a big one these days. Seems like every other day there's a new data breach in the headlines. How can data science help us stay ahead of these cyber threats?
Well, imagine a security system that doesn't just react to attacks, but can actually predict them before they happen.
Like a virtual crystal ball for cyber threats.
Kind of. By analyzing patterns in past attacks, security systems can identify vulnerabilities and proactively strengthen their defenses.
So instead of just playing defense, we can start playing offense in the cybersecurity game.
Exactly. And this has implications beyond just protecting companies. Think about all the personal data we share online, our browsing history, financial information, even our health records. Data science plays a crucial role in safeguarding our privacy and security in this digital world.
That's really important. It makes you realize how much we rely on data security every day.
Absolutely. And speaking of data, I'd like to shift gears a bit and talk about big data.
Okay, big data. The book mentions that by 2020, all our digital activity was creating 1.7 millibit of data every second for every person on the planet.
Yeah, it's almost impossible to wrap your head around.
Right. So what exactly are we talking about when we say big data? Is it just about the sheer amount of data?
It's definitely about volume, but it's more than that. Big data is generally characterized by 3 V's: volume, velocity, and variety.
3 V's, okay. We talked about volume, but what about velocity and variety?
Yeah. Velocity refers to the speed at which data is being generated and collected. Think about all the social media posts, online transactions, sensor readings. It's a constant flood of information.
It's like trying to drink from a fire hose.
Exactly. And then there's variety. Big data isn't just neat rows and columns in a spreadsheet. It's a mix of text, images, audio, video, all sorts of unstructured and semi-structured data.
That sounds like a real challenge for analysis.
It is. That's where big data analytics comes in. It focuses on finding meaningful patterns and insights within this massive amount of information.
So it's like the key to unlocking the potential of big data.
You could say that. It's what allows companies like Amazon to personalize your shopping experience, or Netflix to recommend shows you might like. Even healthcare providers are using it to develop more effective treatments.
It sounds like big data analytics is already having a huge impact on so many different industries. Can you give us some specific examples?
Absolutely. Take product development, for instance. A company like Procter& Gamble uses big data from social media, test markets, and focus groups to understand consumer wants and needs. This allows them to predict the success of a product before it even hits the shelves.
That's incredible. They're essentially getting a sneak peek into the future of consumer demand.
Precisely. And it's not just consumer goods. The travel industry uses big data to personalize travel recommendations and offer tailored deals. Retail giants like Amazon use it to create those eerily accurate product recommendations.
It seems like everyone is using big data these days. But what about data mining? Where does that fit in? Is it the same as big data analytics?
Data mining is actually a crucial part of big data analytics. It's the process of discovering hidden patterns and relationships within large data sets.
So if big data is the mountain, then data mining is like digging for gold.
I like that analogy. You're sifting through a mountain of data to find those valuable nuggets of insight.
What does that process actually look like? Do you just throw data at an algorithm and hope for the best?
Not quite. There's actually a structured process involved, typically consisting of 6 steps. Business understanding, data preparation, data modeling, evaluation, and deployment.
Okay, 6 steps. Let's break those down a bit. What does business understanding entail?
It's all about defining the goals of your data mining project. What problem are you trying to solve? What questions are you trying to answer? Having a clear understanding of your objectives is crucial before you even begin collecting data.
It's like having a roadmap before you embark on a journey, right? You need to know where you're going.
Exactly. Once you have a destination in mind, you move on to data understanding. This involves exploring the data you have, identifying its strengths and weaknesses, and ensuring it's relevant to your objectives.
So it's like doing some reconnaissance before you launch a full-scale data mining operation.
Great analogy. Once you understand your data, you can move on to data preparation, which is often the most time-consuming step. This involves cleaning the data, handling any missing values, and transforming it into a format suitable for analysis.
It's like prepping the ingredients before you start cooking. You want everything to be clean, chopped, and ready to go.
Perfect. And only then can you move on to data modeling, where you apply algorithms and machine learning techniques to build models that uncover hidden patterns and make predictions.
This is where the magic happens, transforming raw data into actionable insights.
Precisely. But building a model is only half the battle. Next comes evaluation, where you assess how well your model performs. Does it meet your objectives? Is it making accurate predictions?
It's like testing a new recipe to see if it actually tastes good.
Exactly. And if your model passes the test, you can finally move on to deployment, where you integrate it into your business processes and start reaping the benefits of your work.
It's a journey with multiple steps, but it sounds like the payoff can be huge.
Absolutely. But like any powerful tool, data mining has its limitations.
What are some of the challenges we should be aware of?
One of the biggest is dealing with the sheer volume and complexity of big data. Those 3 V's we discussed, volume, velocity, and variety, can be a real challenge.
Right, it's like trying to drink from that fire hose again.
Exactly. And traditional data mining techniques were designed for structured data, while big data often includes unstructured data like text, images, and audio.
So we need more sophisticated tools and techniques to handle this new kind of data.
We do. And we also need to be mindful of overfitting, where a model becomes too tailored to the data it was trained on and doesn't work well with new data.
How do we avoid that?
We need to ensure our models are robust and can handle new unseen data. It's like making sure your recipe works with any brand of flour.
Makes sense. Any other challenges we should be aware of?
One more crucial consideration is data privacy and security. With so much data being collected, it's paramount to handle it responsibly and ethically. Companies need strong data governance policies to protect sensitive information and comply with regulations.
It's a delicate balance, finding the right way to leverage data while respecting privacy. But it sounds like data mining is constantly evolving to address these challenges. What are some of the new trends emerging in the field?
Well, the constant evolution is part of what makes it so fascinating. One trend is the increasing speed and power of computing. Data mining tools are getting faster and more efficient, allowing us to analyze even larger and more complex data sets.
So we're getting better at handling that fire hose of data.
We're making progress. Another trend is the rise of cloud computing. Cloud-based data mining platforms offer scalability and flexibility, giving businesses of all sizes access to powerful tools without needing expensive hardware.
It's like democratizing access to data mining, making it available to everyone.
Precisely. And another exciting trend is web mining, applying data mining techniques to the vast amount of data on the internet. Companies like Amazon use web mining to understand customer behavior, track trends, and personalize your shopping experience.
Wow, it's like having a data-driven window into the collective mind of the internet.
You could say that. Web mining is just one example of how data mining is becoming more specialized. We now have tools specifically designed for different industries and applications, allowing for more targeted and insightful results.
Fascinating. The book mentions some popular data mining tools. Can you tell us more about them?
Of course. One that's great for beginners is Orange. It's an open source software written in Python known for its user-friendly interface and powerful data visualization capabilities.
So it's like a data mining starter kit.
Exactly. For a more advanced open source option, there's RapidMiner. It's written in Java and offers a comprehensive set of algorithms and can handle both structured and unstructured data.
So stepping up from the starter kit to a professional-grade toolkit.
That's a good way to put it. And for businesses dealing with massive data sets, there's Mahout. It's specifically designed for machine learning on big data built on top of Hadoop, a framework for distributed computing. It offers a wide range of algorithms for clustering, classification, and collaborative filtering.
It sounds like having an industrial-strength data mining machine at your disposal.
You got it. These are just a few examples, and the choice depends on the specific needs of the business and the project's complexity. But the principles of data mining remain the same: extract, transform, load, model, evaluate, and deploy.
It's a journey, but one that can lead to some amazing insights. Now, the book also discusses data analysis frameworks, which sounds intriguing. Can you tell us more about them?
Think of data analysis frameworks as blueprints for building data analysis solutions. They provide a structured approach, guiding you through the entire process.
Like instructions for building a data analysis masterpiece.
That's a great way to put it. One framework discussed is ensemble learning, a technique for improving the accuracy of machine learning models.
Ensemble learning sounds familiar. Didn't we talk about that with random forest?
You're exactly right. Random forest is a type of ensemble learning. It combines the predictions of multiple models, almost like getting a second opinion, to produce a more accurate and robust prediction.
So it's like getting a consensus from a panel of experts instead of relying on one opinion.
Precisely. There are two main approaches: bagging and boosting. Bagging trains multiple models on different subsets of data and then combines their predictions. Boosting trains models sequentially, with each model correcting the errors of the previous one.
So bagging is like a diverse group of experts giving their opinions, while boosting is like specialists refining each other's work.
Nice analogy. Both approaches have strengths and weaknesses depending on the problem. Another framework discussed is decision trees.
Decision trees sound interesting. How do they work?
Imagine a tree-like structure where each branch is a decision point and each leaf is a final outcome. It's a flowchart-like model for making predictions based on a series of decisions.
Like a choose-your-own-adventure for data analysis.
I love that. And they're surprisingly powerful, easy to understand, can handle different types of data, and are robust to noisy data.
Sounds like a great all-around tool. The book also mentions random forest, which sounds like a bunch of decision trees combined.
You're sharp. Random forest is an ensemble learning method that uses multiple decision trees to make predictions. It's a bagging technique combining predictions from many trees, each trained on a different random subset of the data.
So we're getting the wisdom of an entire forest of decision trees.
Exactly. By combining predictions, random forest is more accurate than a single tree and less prone to overfitting, making it a more robust and reliable model.
Powerful. Are there any downsides?
Well, they can be computationally expensive to train, especially with large data sets, and they can be a bit of a black box, making it hard to understand how they make predictions. But overall, it's a powerful and versatile technique widely used in data mining and machine learning.
It's amazing how these frameworks build upon each other. The book also goes into specific data analysis libraries. Can you tell us more about those?
Absolutely. It covers some essential libraries for data science in Python, including scikit-learn, SciPy, SymPy, NumPy, Matplotlib, Pandas, IPython, and Jupyter Notebook. They're the building blocks for any aspiring data scientist.
Okay, lots of building blocks. Let's start with scikit-learn. What's that all about?
Scikit-learn is considered the gold standard for machine learning in Python. It's a comprehensive library with a wide range of algorithms for classification, regression, clustering, dimensionality reduction, model selection, and preprocessing. It's built on other libraries like NumPy and SciPy and is known for its user-friendly interface and efficient implementation.
So a one-stop shop for machine learning in Python.
You could say that. It's constantly being updated with new algorithms and features, which is important in such a fast-evolving field.
Makes sense. What about SciPy? How does it differ from scikit-learn?
SciPy is more of a general-purpose scientific computing library. It provides tools for numerical integration, optimization, interpolation, linear algebra, signal processing, image processing, and more. While scikit-learn focuses on machine learning, SciPy provides the foundation for many scientific and technical applications, including machine learning.
So SciPy is like the foundation, and scikit-learn builds on top of it.
Exactly. Then there's SIMPy, a library for symbolic mathematics. It lets you perform computations using symbols instead of numbers, which is powerful for solving mathematical problems in fields like physics and engineering.
Like having a digital mathematician at your fingertips.
Precisely. NumPy is another essential library for data science in Python. It provides a powerful n-dimensional array object, a fundamental data structure for representing numerical data. It also offers functions for mathematical operations on arrays.
So NumPy is the backbone of numerical computing in Python.
You got it. It's used in many other data science libraries, including scikit-learn and pandas.
And pandas, what can you tell us about that one?
Pandas is all about data manipulation and analysis. It offers two powerful data structure series and data frames for working with structured data like tables and spreadsheets. It also has functions for cleaning, transforming, and analyzing data, making it essential for data exploration and what data scientists call data wrangling.
So pandas like a data chef, prepping and serving your data in a digestible format.
Love that analogy. It works seamlessly with other libraries like NumPy and Matplotlib, making it versatile and powerful.
What about Matplotlib? What role does it play?
Matplotlib is the visualization expert. It's a library for creating plots, charts, and graphs in Python. It's essential for exploring your data and communicating insights to others.
So Matplotlib is the artist of the data science world, bringing data to life visually.
Exactly. It's highly customizable, allowing for visually appealing and informative graphics. Now, IPython and Jupyter Notebook are a bit different. They provide interactive environments for working with Python code and data.
So less about crunching numbers and more about creating a space for experimentation and exploration.
Precisely. IPython is an enhanced interactive Python shell with features like tab completion, syntax highlighting, and object introspection. Jupyter Notebook is a web-based interactive computing environment combining code, text, images, and even videos in a single document.
So IPython is like a souped-up Python terminal, while Jupyter Notebook is the digital lab notebook for data science.
You got it. They're powerful tools for exploring data, prototyping code, and sharing your work.
It's amazing how these libraries create such a rich ecosystem for data science in Python.
It is. And there's so much more to explore.
I'm ready for more. Okay, so let's talk about predictive analytics. I gotta admit, it sounds kind of like science fiction, using data to predict the future.
It does sound a bit futuristic, but it's actually already all around us. Think about how companies use sales data to forecast demand, or how financial institutions assess credit risk.
Oh yeah, I guess that makes sense.
They're using historical data to identify patterns that can help them predict what might happen next.
So it's like a data-driven crystal ball. But instead of vague predictions, we're getting concrete insights.
Exactly. And predictive analytics goes beyond just forecasting. It's also about understanding the factors that drive those predictions.
So we're not just passively predicting the future. We can actually try to shape it.
Exactly. And that's what makes it so powerful. It allows us to move beyond simply reacting to events and instead be proactive.
I see. So it's about understanding the why behind the what. Okay, that makes sense. Now, the book spends some time talking about customer analytics and how that relates to predictive analytics. How does that work?
Well, one application is customer segmentation. That's where you divide your customer base into groups based on shared characteristics.
Okay, like demographics or buying habits.
Exactly, things like that. And by understanding these different customer segments, businesses can tailor their marketing, personalize recommendations, and even predict which customers are likely to leave.
So you're recognizing that not all customers are the same.
Right. Another application is predicting customer lifetime value, estimating the total revenue a customer will generate over their entire relationship with your company.
Oh, so you're thinking long-term, not just focusing on the immediate sale.
Exactly. This helps businesses focus on keeping their most valuable customers and make strategic decisions for long-term profitability.
That's really interesting. It sounds like customer analytics can be applied in so many different ways.
It can. Predicting product demand, optimizing pricing strategies, the possibilities are pretty vast. It all boils down to collecting the right data, analyzing it properly, and using those insights to make good business decisions.
So data is really at the heart of all of this.
Okay.
Now, the book also mentions the marketing and sales funnel. How does that concept fit into all of this?
Well, think of it as a visual representation of the customer journey. From the moment a potential customer becomes aware of your product, all the way to the final purchase.
Oh, okay.
It's a framework for understanding the steps customers go through and identifying areas where you can improve your efforts.
So it's like a map of the customer's path to buying something.
Exactly. And customer analytics can be incredibly valuable for optimizing that path.
Like figuring out where customers are getting lost along the way.
Exactly. You can analyze the data to figure out why customers are dropping off and then make changes to improve your conversion rates.
So data can help you plug those leaks in your sales funnel.
That's a great way to think about it. And then predictive analytics can take this even further.
How so?
Well, by analyzing historical customer data, you can predict which customers are most likely to convert at each stage.
And then you can personalize your marketing even more.
Exactly. Okay, now, the book specifically talks about a tool called Get Response Autofunnel.
Oh yeah, what's that all about?
Well, building marketing funnels used to be a very manual, time-consuming process.
Yeah.
You had to piece together different tools and platforms, but Get Response Autofunnel aims to simplify this by providing an all-in-one solution.
So it's like an automated system for creating and managing those funnels.
Exactly. It's got pre-built templates for different types of funnels like lead generation, sales funnels, webinar funnels. It even integrates with other tools like email platforms and payment processors.
So it sounds pretty efficient.
Uh-huh.
Does the book say anything about how effective those tools are?
Yeah, it really emphasizes that they can be a game changer, particularly for small businesses that might not have the resources to manage everything manually. Automating those tasks frees up a lot of time for them to focus on other things.
It's like having a virtual marketing assistant working for you 24/7. That's pretty cool. All right, so wanted to talk a little bit about personalized marketing. Since it feels like it's everywhere these days, are we going to be seeing more and more of that?
I think it's safe to say personalization is here to stay, and it's only going to get more sophisticated as technology advances.
Okay.
And data is really the key to making it work. The more data you have about your customers, the better you can understand their needs and tailor your marketing accordingly.
So it's about moving away from that generic one-size-fits-all approach to marketing.
Exactly. It's about creating a truly unique experience for each individual customer.
Okay, so how are companies actually doing this?
Well, one way is through targeted advertising. They analyze customer data to figure out the best channels to reach them, personalize the ad creative, and even try to predict which customers are most likely to click.
And that's all based on data.
Yes. Another example is personalized messaging. Companies use data to understand customer preferences and tailor their emails, social media posts, even their website content to create a more relevant experience.
It's all about making every interaction feel personalized and
Yeah.
relevant to the customer's needs. So it's not just about trying to sell them something.
Right. The book really emphasizes that. It's about building a strong, lasting relationship with your customers.
And when you show them that you get them, they're more likely to stick around.
Exactly. And a big part of that is using data to create what are called dynamic websites.
Dynamic websites, how are those different?
Well, traditional websites were very static. The content was the same for everyone who visited. But dynamic websites can actually change their content depending on who's browsing.
So it's a personalized website experience.
Exactly. And a lot of this is powered by AI and machine learning.
Wow.
Like a dynamic website might use image recognition to identify products you've looked at before and then recommend similar ones on your next visit.
So it's like having a personal shopper built into the website.
That's a great way to put it. The book even highlights a company called Bookmark that's using AI to create custom-designed websites for businesses.
Wait, so AI can design websites now?
That's right. Bookmark's AI design assistant uses machine learning to analyze data about a business and create a website tailored to their needs.
It's amazing how much AI is changing things. This deep dive has been fascinating. We've covered so much ground, from data science basics to these incredible tools and technologies that are revolutionizing how businesses work.
I agree. It's been a great deep dive.
I feel like I've learned so much, and I'm really excited to start putting some of these ideas into practice.
Well, the book we've been discussing is a fantastic resource for anyone who wants to delve deeper.
Yes, definitely check it out if you're interested in learning more. So as we wrap up this episode, what's the one key takeaway you want listeners to remember?
The key takeaway is that data is everywhere, and it's only becoming more important. No matter what you do, understanding data is essential for success. It's a new kind of literacy for the digital age.
Well said. And this deep dive has given you a taste of what's possible. Now it's time to go explore for yourself.
Exactly.
Thank you for joining us on this deep dive into the world of data science and Python. We'll see you next time.